having finished our syllabus, remember we have finished our syllabus in electrical installation. So today I want us to do a review of some basic things in electrical installation and applications. So today it just be a review, and after the review, then we'll be able to ask some questions. So in case you lose my voice, maybe you don't hear me, you just unmute and talk. I might not be able to see the message because I'll maximize the screen. So under basic installation, we normally have the electrical components, the wiring systems that we have, the components and the elements and the electrical cables that we have. We also learned differentiating between earthing and bonding. And remember, you were not in class yesterday. Yesterday we were talking with Salad, the difference between earthing and bonding. And then the possible conductive parts of structures, and then the purpose and function of the earth protection. Why is it important to install an earthing protection in a building? We learned that. So and also the basic principles of shock protection, circuit overload, and short circuit protection. Those are some of the things that we want to review as we do the review of what we've been learning. So components, parts of an electrical circuit. What does an electrical circuit comprise of? On completion of this topic, a candidate will be able to state the component parts of the electric circuit. Remember, we normally have the BS standards. These are the standards that are normally given. Remember, our country uses the British standards of electrical installation. These are the standards that are recommended when we're doing any electrical installation. We should be able to adhere to the standards. So one of the things or the components of an electrical circuit that we have to know is the source of supply. So often a circuit is thought to be of being a load and a conductor supplying the load. So the circuit is just the load and the conductors that are supplying the load. So the load, for example, of a circuit is an iron box or a computer. And the conduits or the conductors that are supplying the load are the cables. So that is a circuit. However, in reality, they are only part of the circuit. In order for current to flow, two conditions have to be met. So one of the conditions is there has to be a potential difference applied across the current or the voltage. And also there has to be complete circuit circle for the current to flow around. So the source of supply can be AC. The source of supply can be AC or DC. If a DC supply is required, then this is derived from the battery. For an AC supply, then either the AC generator or a DC generator with electrical components to rectify the supply can be used. Now, an AC supply can be obtained directly from the mains. That is, for single phase, that is 250 volts. For a three-phase is normally 415 volts for those. And then the size and type of voltage required for the supply is determined by the load equipment used. So all electrical equipment will have a plate attached to it indicating its safe working voltage. Now we have a circuit conductor cables. These are also some of the components of the circuit. The circuit conductor cables. So a circuit conductors are those parts of the circuit. They are those parts of the circuits which the current passes through. Those are the conductors. And these are the cables. Now the cables have two components to them. One of the conductors itself. One is the conductor itself. This is usually made of copper. The other part is insulation, which is usually made from the PVC. PVC is plastic-like, which flows a sheath around the conductor. The insulators are required to, number one, prevent the conductors touching together. This could short the circuit and prevent it from working. So the conductor cables is the actual thing or the actual element that is able to transmit power or voltage. And then this conductor has to be covered, has to be protected by something called an insulator. So this insulation is normally plastic in nature. So the type of insulator required is determined by the voltage which is to be applied to the cable. Now cables come as either single or multi-core cables. Both have an overall shape to keep all the associated cables together and provide a minimal degree of mechanical protection. Now we have an appendix 4, which is on the IE regulations. I remember sending you this IE regulation. Hope you guys are reading it. I give details of the size and type of cables available to use. So we'll be looking in more details the type of cables later. So that is a review on components of the circuit. So the size of the conductor also used in the circuit is important and needs to be calculated accurately. So we need to be sure that the conductor is large enough to carry the current produced by the load, and be sure that the load receives sufficient voltage for it to work safely. Now the current protection. What is current protection? Now, every current requires protection if, in the event of fault, damage is to be avoided. Now, the inclusion into the circuit or this suitably rated fuse or protective device, such as a miniature circuit breaker, that is the MCB, will protect both the load and the cable supplying the load from the heat damage associated with the large fault currents. Now, protective devices are used to provide a circuit with overload protection, short circuit protection, and shock protection. So when we have things like circuit breakers, they are able to provide the load, that is our appliances or the whole circuit, from things like overload. When there is an overload, the circuit breaker comes in and cuts off the supply. Or when there's a short circuit, instead of damaging the appliances, all the load, then the circuit breaker comes in to protect the circuit. Now, the protective device or a fuse is deliberately designed to be a weak link in a circuit. When the current increases in a level where damage can be sustained, now the fuse operates and automatically interrupts the supply of the current. So as the fuse is part of the circuit, once it is broken, it also breaks the flow within the circuit, ending the supply. Now, circuits supplied at voltages below 50 volts may be required to have current protection for functional reasons. Now, circuits supplied at 50 volts and above are required to have current protection that complies with the requirements of this standard. That is the BS 7671 standard. Now, for example, a low voltage circuit above 50 volts but not exceeding 1,000 volts, supplying socket outlets must be automatically disconnected in the event of the earth fault between 0 to 4 seconds. And remember, these protective devices like the circuit breaker are normally timed. They operate within a limited given of time. So some of the protective devices we have are things like the rewirable fuses. We have rewirable fuses. These are fuses that are connected with a wire, so when the wire burns off, it can easily be replaced. We have the cartridge fuses. We have the MCBs, the normal MCBs, then the RCBOs. Now, circuit control. What is circuit control? It is a virtual that any circuit, no matter its level of complexity, can be controlled. So this could either a simple switch that is allowing us to turn the circuit on or off, or a time switch which activates the circuit at a certain time. Now, for example, things like street lights. Street lights, these are time switch circuits that are controlled by timing. So they can be those ones that can sense darkness and then they switch on, or those that are timed. The moment it is 6 a.m., they switch off, and then the moment it's 6 p.m., they switch on. So those are examples of time switch circuits. And then we have a float switch which controls the water level in a pump. So there are also float switches where when water is being pumped into a pump and then the water seems to be full, the tank seems to be full, and then this switch is able to switch off the water flow or the pump automatically. So in the isolation is the ability to remove the supply from all the live conductors, such as at the main switch to a complete isolation. Emergency switching is another area of control that is required for some circuits. Now, this allows us to press one button and turn off the main supply to a stress of a series of equipment in event of danger. Now a load. What is a load in a circuit? Remember we have talked about the components, we have talked about the conductors, we have talked about the protection. Now we are talking about the load. What is the load? The load refers to the item that requires the supply in order to function. For example, this might mean that the lights in a circuit are a heater or a motor drive or a pump. In any item of the equipment, that is or a combination of these. So that requires an electrical supply in order for them to work. So electrical loads are rated in watts or kilowatts. So the size of the load is generally stamped on the equipment or marked on the nameplate. This can contain the rating in watts. Or for example, like the motors that are always in supply, they have to contain the rating in watts, the frequency of the supply, which is in our country, we normally use 50 hertz. Then the supply voltage, then the full load current. These are some of the things that are rated. These are some of the ratings that are put on the nameplate of any load. And we are saying that an example of a loading is an iron box, we have a motor, we have a drive pump, we have a heater, we have lights, we have all those things that drain power are called loads. Determining appropriate wiring systems, enclosures, and equipment. Now, this is another thing that I want us to go through. Determining how to determine the appropriate wiring system. How do we determine the appropriate wiring system? So, in order to do the BS 7671 requires to determine the characteristics. Requires the design provide the protection of persons. So in order to for this standard requires to determine the characteristics of the available supply. So this can be done by calculations, measurements, inquiry, or inspection of the existing suppliers. Now the characteristics that need to be determined are: number one, the nature of the current, that is either AC or DC, the number of conductors, that is voltage or the voltage. We need to determine the voltage, we need to determine the frequency, we need to determine the maximum current allowed, we need to determine the protective short circuit current, the earth loop impedance, the nature and size of the load, the number and type of current circuits required, and the location and all special conditions that may apply. So this should take into account the nature of the location and the structure. Now, insulation colors. These are some of the insulation colors. Remember, we are doing a revision of what we have always done. So for the AC supply circuits, the face of a single phase is brown. That it can either brown. This is a single phase, the one that or red can either be brown or red. Then the neutral of the supply of the three phase is blue. And then the phase of the three phase now, the AC circuit is brown. So those are the color codes of the supplies, of the insulations of the supplies. So the conductors are here. Again, the color codings are there. So I'll go to this, wiring in conduit and trunking. Now, wiring is a type of insulation that is carried out using the PVC single core insulated cables. This code number is manufacturer's code used to denote different types of cable. So the phase, that is the live conductor, is taken directly to the first switch and looped from the switch to all the remaining lights connected to it. Now, in that particular circuit, the neutral conductor is taken directly to the lighting outlet, that is the luminance, and left between all the remaining luminance on that circuit. So the switch wire is run between the switch and the luminance it controls. Wiring use multiple composite cables. Now, wiring using multiple or composite cables. This is a type of cable that is normally sheathed, that is multiple, twin, and earth, or triple and earth, that is two-way and interminate circuits only. So, a loop-in and joint box method may be employed with this type of insulation. So, in many instances, the loop-in system is specified as there are no joint boxes installed at all. Terminations are already accessible at the switches and the sealing process. So with the joint box system, normally only one of the cable is run to each wiring outlet. So that is a wiring. Now we have one-way switching. One-way switching. The most common circuit possible in one-way switch controlling one light, that is as shown in this. So one-way switching, you can see this. It can. This is when it is open, and this is when it's closed. It's just one way, one gun. It's just a cut. You can see how it appears. So once operated, the switch contact is held in place mechanically, and therefore the electricity is continually flowing through the light. So in other words, we supply the switch fed terminal point at point A. We supply at point A, operate the switch, and come out of the wire at point B. So when we operate the switch, operating the switch means switching it on, then it comes out at point B. So that is the wire terminal. That is the neutral is there. Now one-way light switching for wiring with a single core cable. That is single core cable is one core. That is old cable color code. You can see this is the neutral. You can see this is the phase. The phase comes in. It comes here. This is the conductive. This is the protective conductor that is here. And we have, this is the maybe a terminal or a junction box that is here where they meet. It's called a JB, junction box. So when the neutral goes direct from the supply to the light, then the live has to go to the switch. This is and then from here it is cut. The switch is can either be a junction box or a switch. So the switch is here, and then the wire now to that lights this. So you can see this is a 3-plate ceiling rose that is here. So our live comes here, goes to the switch, and goes there. And then we have this. The earthing does not even get in here. It touches this point and goes to the lighting. Now we have a one-way switching for wiring with a single core cable, that is the new color codings. This is just a change of the color coding. But this one is what we normally use in our country, Kenya. Two-way switching. Sometimes we need to switch a light on or off from one or more locations, e.g. at opposite ends of the long corridor with when it is required. A different switching arrangement must be used. So the most common being the two-way switch circuit. In this type of circuit, the switch fed is feeding one two-way switch, and the switch strappers, that is then the link of the two switches together. In other words, the supply of the switch feeders at this terminal. So you can see this is a two-way switching. You can see this is our supply and this is the switch. So when it connects normally closed, and you can see how it can either be switched on from B or C. However, depending on the switch contact position, the electricity can come out of either terminals B or C. So you can see because it's a two-way. So if we now operate the switch, now the contact would move across to energize the terminal C. Please note that the actual switch terminals are not marked in this way. Now switching of lighting circuits. Now by connecting together the two two-way switches, we now have arbitrarily at each of the either energizes the switch wire going through the light or to de-energize it. So this is why this system is ideal for controlling lighting on corridors and staircases. So you can see this is the common, this is the line 1, line 2, line 1, line 1, line 2, line 2, and then this is the common, this is the light. So however, operate the second switch. So these things I know you've already done, and you can do them practically in the labs. So in the intermediate switching, I'll not now talk much there because it's supposed to be done practically in class. So in intermediate switching, you can see the position for the position 1, L1, L2. They are normally linked. Now we can see position 2, this position 1 and this position 2. That is how we can wire the intermediate switching. However, by operating the intermediate switch, we can route the switch feed along another section of the strapper, and the energies of the switch wire terminals, and therefore the luminaire will come on as shown in the figure. So to use the example along the main corridor, these are mostly used along the main corridors that is coming off it. So if we have an intermediate switch at each of the junction with the main corridor, anyone joining or leaving the main corridor now has the ability to switch the luminaires on or off. So you can see how the wiring is done. This is the neutral, this is the earthing wire. They go straight to the bulb. This is the face, connects to line 1, and then it's joined to line 1 again, and then it supplies power here. So when this is linked, this is gives line 2. Line 2 is again connected to line 2. So Salad, you just come in. Okay, let us proceed. And then now this circuit. So wiring of multiple cables. Wiring of multiple cables. How are the what are multiple cables? Multiple cables are cables that have several strands. Cables that is not just one strand. So multiple cables, commonly referred to a twin and earth, are basically a 3-core cable consisting of a face, neutral, and earth conductor. Both the face and the neutral conductors consist of the copper conductors insulated with colored insulation. Now the earth being an uninsulated bare copper conductor sandwiched in between the face and the neutral. So in the old colors, that is the correct use of the cable. Remember that we are still using the red as the face. Salad, before you came in, I said we were doing a revision. These are things that we had already done. We have finished our syllabus. So we are going through what we have learned so that we can brush over maybe something that some of you could have forgotten. So this is the old core color cabling for the multiple. Multiple means we have, it is a cable that is the twin with earth. Twin with earth meaning it has the neutral, it has the live, and it has the earthing in the same cable. Meaning the cable has one insulator. They are not singles. So we go down and say the two-way switching and conversion circuit. This method of switching using multiple cables requires the use of the 4-cable. This is a cable that has three colored and insulated conductors and the bare earth conductor. So the 3 colored conductors are in the all colors. That is the color code. That is the red, yellow, and blue. This type of cables is normally only stocked in 1.5 millimeters. So those are some of the installation for the old. Now the intermediate switching illustrated. This one is supposed to be animated. When we come back to the university, we'll be able to remind ourselves how we can use all these types of switching. Now wiring using a junction box, a junction or a junction box. What is a junction box? A junction box is where the cables meet. Where the cables meet before they can supply the bulb or the lighting point. So this method of wiring is considered as somewhat old-fashioned, as it has now been superseded by the loop-in method. However, that is not to say that you will not come across this method in the millions of households in the country that we have a junction box method installed. So care should be taken when wiring junction boxes, and the following precautions should be observed. So one of the precautions is the protective outer sheath should be taken inside the junction box, entries to the minimum of 10 millimeters, meaning when we are wiring using the junction box method, we should not leave exposed cables that do not have insulation outside, because they can bring about a short circuiting, or they can make the wires to touch each other, bringing a short circuit. Now, another precaution that we have to take is where terminations are made into the connector, into a connector, only sufficient insulation should be removed to make the termination. So we only remove sufficient insulation. A sufficient slack should be left inside the junction box to prevent excess tension on conductors. The cable should be inserted so that they are not crossing. They should be neat and fitted. They should be neat and fitted. That is wiring in a junction box. The correct size of the joint box should be used, and then the joint box should also be secured to a platform fitted between the floor and the ceiling joints. So we have the rings, radius, and spars. So before we go to the rings, radius, and spars, this is now the power outlet. I would like to hear some comments or questions from what we have learned so far. Unmute your mics. I want to listen to you guys. Salad, you just came in, you didn't even greet us. Unmute your mics. Yes, Peter, say something.
I don't have much to say.
You don't have much to say, but did you understand anything?
Yes, I understand everything.
Yes, Salad, tell us something from where you met us.
So,
yes? Yes?
sawa class.
Uko sawa? Sawa. So, tuendelee. Let us proceed because naona time pia inaendelea kusonga. Let us just mute your mics na tuendelee. So the rings, radius, and spars. So before early 1950s, different types of sizes of socket outlets and plugs were in use. So in domestic premises, which was very annoying and inconvenient. So in the 1949s, the 5 ampere, 15 ampere socket outlets were deemed obsolete. An agreement was reached that a standard socket, that is the 13 ampere socket outlet, with a fused plug. It normally has a fused plug of the BC, that is the BS standard 1363. In this section, we will be looking at the standard power out circuits arrangement found in the domestic premises. So in particular, the following will be investigated. That is the ring circuits, the fused spars, the permanently connected equipment, the radio circuits, and the non-fused spars. So what are these ring circuits? So in the system, the phase, the neutral circuit protective conductors are connected. So in these respective terminals at the consumer unit, looked into each socket outlet into and then returned into their respective terminals in the consumer unit, thus forming a ring. So each socket outlet has 2 connections back to the main supply. Back to the main supply. So the requirements for the standard domestic ring circuit are as shown in the bulletin points below. So an unlimited number of socket outlets may be installed provided the following points are taken into account. So each socket outlet that is of a twin or multiple sockets is to be regarded as a one socket outlet. So we are saying that each socket outlet of twin or multiple socket is to be regarded as a one socket outlet. That is, even if it is a twin, it is called a one socket outlet. The floor area served by a single 30 ampere or 32 ampere ring final circuit must be exceeded must not exceed a 100 millimeter square domestic installation. Those are some of the rules. And the consideration must be given to the loading of the ring main, that is especially in kitchens and utility rooms, which may require separate circuits. Now, when more than one ring is installed in the same premises, the socket outlets installed should be reasonably shared among the ring circuits so that the access load is balanced. Now, immersion heaters. What are immersion heaters? Immersion heaters storage vessels in excess of 15 liters capacity or permanently connected heat appliances forming part of the comprehensive space heating installation are supplied by their own separate circuits. Yes, please just mute your mic so that we proceed and continue. So this is a typical domestic ring circuit. You can see this is a ring circuit. A ring means it taps a power from the source and then it goes all the way. You can see the source is here, taps, and they just have a ring, and then there. And then you can see an unfused spar. This is a spar, meaning it is tapped from one socket. Any power that is tapped directly out from one socket is called a spar or stationary appliance. So permanently connected equipment. Now, permanently connected equipment should be locally protected by a fuse which does not exceed 13 amperes and be controlled by a switch complying with the BS 7671 chapter 46. That is, you can get it in the IE regulation. And all protected by a circuit breaker that is not exceeding a rating of 16 amperes. Non-fused spars. What are non-fused spars? A spar may be installed on a ring circuit. This may be fused, but it is more common to install an unfused spar that is connected to a circuit at a terminus of a socket outlet, at junction boxes, or the origin of the circuit on distribution board. So non-fused spars may supply only one single or one twin socket outlet or one item of permanently connected equipment. So the total number of non-fused spars should not exceed a total number of socket outlets and items of fused equipment connected directly to the ring. So the size of the conductor of the non-fused spar must be the same of the size of the conductor as used in the circuit. So those are non-fused spars. Those are non-fused spar circuit. This is a ring and then it is tapped for the single socket and for the double socket. Then the fused spar. A fused spar is connected in a circuit through a fused connection unit. So the fuse incorporated should be related to the current carrying capacity of the cable used for the spar, but should not exceed 13 amperes. So the sockets are wired through a fused spar, and the minimum size of conductors is 1.5 millimeters square for rubber or the PVC installed cables with copper conductors, and the 1 millimeter for the mineral insulated cable, which are normally used in industries. Radio circuits. What are radio circuits? A radio circuit a radio circuit conductors do not form a loop, but finish at the last outlet. That is, as the wire of the ring circuit, the number of outlets in any circuit is unlimited in the floor area up to the maximum allowed. So in each case, this will be determined by the estimated load and shock protection constraints. Okay, at least we have reminded ourselves on that. Components and elements of electrical cables. On completion of this, on selecting cables of an electrical installation is very important. That is, consideration must be given to the following criteria in order to ensure the correct type of cable is chosen. We have the conductor material. We have the conductor size, insulation, and environmental condition. Now, conductor material, copper and aluminum. The choice generally is between copper and aluminum. That is, copper has a better conductivity for a given cross-section area and is preferably, but in its cost has risen over the years. Aluminum conductors are now sometimes preferred for the minimum and large range of cables. And the large range of cables, all cables smaller than 16 millimeters cross-section area. Now, advantages and disadvantages of certain conductors. If you have a copper conductor, what is the advantage? It is easier to join and terminate, a smaller cross-section area for given current rating. Disadvantage is more costly and heavier. What about aluminum? Aluminum is cheaper, it is lighter, and not recommended for use in hazardous areas. And the disadvantages is bulkier for given current rating. Now, other conductor materials, we have canadium copper, we have steel reinforced aluminum, silver, copper clad cables, that is copper. Now, the conductor size. There are many factors that affect the choice of the size of the conductor. That is the load and the future development. The current and the cable is expected to carry can be found from the load, taking into account its possible future development, i.e. changes needs in premises, extensions, and addition. The ambient temperature, that is the hotter the surrounding area, the less the current the cable is permitted to carry. Another one is grouping. These are factors that affect the conductor size. The ambient temperature, the load factor, and development, and then we have the grouping and then type of protection also affect what that can determine the conductor size. The weather placed in thermal insulation also is a factor. Voltage drop is also another factor. So insulation and sheathing. To insulate the conductor of a cable from any surrounding metalwork, materials with extremely good insulating properties must be used. So these materials around the cable is called the sheath. Cables can be insulated in a variety of different situations, and you must take care that the type of insulation and sheath of the chosen cable is suitable for the particular situation. So insulation types now listed below are some of the working properties of more common types of cable insulation. We have the PVC, the synthetic rubber, the silicone rubber, the magnesium oxide, phenol, formaldehyde. So those ones you'll be able to look at them later. They are there in the notes. The environmental conditions. Many factors affect the cable selection, and factors that affect cable selection. Some will be decided by factors previously mentioned, and some by the following. We have the risk of the excessive ambient temperature effect and any surrounding in moisture, the risk of electrolyte action, proximity to corrosion substances. We have the risk of damage by animals, the effect of exposure to direct sunlight, or the risk of mechanical stress, that is the risk of mechanical damage, ambient temperature. Okay, sorry for that. Now, earthing and bonding. And now, Salad, you can remember what we were talking about yesterday, the difference between earthing and bonding. So earthing, the BS 7671 defines earthing as a connection of of any exposed conductor parts of an insulation to its main earthing terminal. This is done to ensure that all the metalwork associated with the electrical insulation is effectively connected to the general mass of the earth. This means that in the event of the earth fault, the voltage developed to earth is restricted to 240 for Kenya, and this is the case even on the 415 three-phase supply. So that is earthing. Earthing is the connection of any exposed conductive parts to the installation of the main earthing terminal. Now, what is bonding? Now, If this fails to define bonding, now, but does define the bonding conductor. So this is a protective conductor providing equipotential bonding. This in turn is defined as an electrical connection maintaining various exposed conductive parts and extraneous conductive parts at substantially the same potential. Now, in order for the current to flow, two conductors have to be, two conditions have to be met. That is, there has to be a circuit, or for current to pass along, there has to be potential difference. By joining together all the metalwork within the insulation, it is now no longer possible for a difference in potential to exist between the various items. Now, earthed potential equipotential bonding and the automatic disconnection of the supply and the supply of the material. Exposed conductive parts. What are these? These are the metallic parts of the electrical system which can be touched and which are not normally live. However, this can become live under fault conditions. So examples of these exposed conductive parts are the metal casing, appliances such as heaters, kettles, ovens, wiring containment such as metal conduit, cable tray, and trunking. And extraneous conductive parts. What are the extraneous conductive parts? These are metallic parts within a building which do not form part of the electrical system, but can also become live under the fault condition. These are what I was talking about yesterday. For example, we have the water and gas pipes, we have air conditioning, boilers, air duct, and systems, structural steelwork in the building. Earthing protection. Earthing protection. Now, the purpose of earthing, by connection to the earth of all metalwork not intended to carry current. Now, the path is provided for leakage current, which can be detected and interrupted by fuses. Okay, sorry, just a minute. Okay, sorry for that. There was a short disturbance. We were talking about exposed conductive parts and the extraneous conductive parts. Now, the bonding, we have said the purpose of earthing is the connection by connecting the earth to all metalwork not intended to carry current, that is, the path is provided for leakage current, which can be detected and interrupted by fuses, current breakers, and residual current devices. So illustrates the earth return path from the consumer's earth and supply earth. So consumer supply, you can see the supply of the company is circuit and the consumer's circuit. This is now the supply of the company circuit, which is now the Kenya Power, where we have the fuse and the cable supplying. And this is the loading. Now the consumer circuit is the loading. Now the connection of the consumer's earth can be by means of either an earth electrode at the building where the earth is required, or maybe in the form of a cable which runs back to the generator or transformer and is then connected to the earth point. And because the transformer or the generator at the point of the supply always has an earth point, the circuit is formed when the earth fault current are flowing. So if these fault currents are large, if these fault currents are large, enough, they will operate the protective device, thereby isolating the circuit. The start point of the secondary winding of the three-phase 4-wire distribution transformer is connected to the earth to maintain the neutral point. So the result of an earthed appliance, look at what happens. If a person touches the appliance shown, which is alive due to a fault, completes the circuit, the earth circuit, and receives the electric shock. This is what happens if a house or an installation is not earthed. So this, you can see this is a supply from the Kenya Power, or supply to a consumer's, to the consumer's meter box. So when it comes, when you don't have an earth, so you can see the fuse and the fault of the appliance casing is here. So anything that a customer touches, if a customer touches any terminal, maybe the loading without an earthing, so this the current will use you as the nearest point to the earth, and you will become the earthing, and then you will be electrocuted. So earthing is a very important thing. So the result of bad earthing, a bad earth circuit, i.e. one with too large resistance, that is, can sometimes have more disastrous effect than having no earth at all. This is shown in the illustration where the earth fault circuit has a high resistance, mainly due to the bad contact at point A. So you can see this. Results of a good earth path is here. You can see it now. Good low resistance earth path. You can see if there is a good earth path in case of a fault. Now a fault is here on these plans. The fault goes through the earthing and goes to the ground, so it not cause any danger to the person using the installation. Earth fault loop impedance. Now the path made or followed by the earth fault current is called the earth fault loop or phase earth loop. So it is termed impedance because part of the circuit is the transformer or generator winding, which is inductive. So this inductance, along with the resistance of the cables to and from the fault, makes up the impedance. So the supply generator of the supply transformer, you can see it here. So electrical protection. On completion of this topic, you can see these. So this is now a shock, direct contact of electric supply. You can see you become the shorter distance to the earth, and then you are shocked. So indirect contact is here, the supply via the proposed conductive path or metalwork that can become live at fault. You can also see here. So both direct and indirect contact or protection against this. So we have protection, we are protecting against any current. So protection against direct current, we have barriers and enclosures. Up to that point, I would wish to hear from you guys. I think the remaining part of the handout I've already forwarded to you. You can look at it, the overload and short circuit, until it finishes. So can I hear comments? Can I have questions? Can I have can I hear something? Yes, Peter, say something.
I have a question. When you're doing an installation for a 2-bedroom house or a 3-bedroom house for an individual, earthing, are you the one to install the earthing, or the Kenya Power will come and install the earthing here in Kenya?
The Kenya Power normally, when they bring their service cable, they normally have to bring an, wherever there is a drop to the house, there has to be an earthing that they tap from the line. So the Kenya Power must provide an earthing that is normally called the PME, the PME, which is dropped at the customer's point. But when you are also doing an installation as an electrician, you also have to do the earthing from the consumer unit end. You have to do the earthing, meaning you have to supply the customer with the earthing. That is, you have to the earth wire has to be connected to something called an earth rod and driven to the ground. So the earthing has to be both ways to maximize the safety that is from any risk. Is that answered?
Yes.
Yes, any question again?
I don't have another question.
You don't have any other question? Salad disappeared?
Yes.
So I want you guys to have a break. We're going to stop here. I want you to have a break, and I would like us to meet at, can we meet at 11 or 11:30 for workshop so that we finish our units today?
Yes, 11:30.
11:30?
Yes.
Sawa. So you have a break, have some breakfast, alafu 11:30 you join for the workshop class. Is that okay?
Yes.
Sawa. Okay, I'm ending the session.